8 videos and we have covered how models get attacked, how agents get hijacked, how data leak. One question left: who is actually allowed to access any of this? And what do you do the moment something goes wrong anyway? Let's close it out. Let's talk about 3 access control models for LLM platform: RBAC, ABAC, and Zero Trust. RBAC, role-based access control. Permission tied to a role: admin, editor, viewer. Simple to reason, but coarse. It doesn't flex well once you have got real multi-tenant complexity. ABAC, attribute-based access control. This is the one that actually holds up for multi-tenant LLM platforms because it can factor in user attributes, resource sensitivity, even environmental conditions like time or device. For more fine-grained tenant isolation than RBAC can express. Zero trust. No implicit trust anywhere, ever, including internal requests, every single API call, every tool invocation, every data access gets authenticated and authorized on its own every time. Let's talk about vector database security. Your database deserves the same respect as the document it represents. Remember, embedding inversion from the data privacy video, same threat, worth repeating here because people forget it. Even embedding that looks like just numbers can be partially reconstructed back into readable text. And there's the practical failure mode. If your RAG system doesn't enforce access control at the retriever layer itself, a user can end up seeing documents they were never authorized to see, even if the original document store was locked down perfectly. Multi-turn conversations bring their own risk. Context window poisoning. Malicious content injected in an early turn can quietly steer the model's behavior several turns later, and the model has no built-in way to distinguish legitimate conversation history from something an attacker slipped in 3 messages ago. Defense here is periodic. Re-inject your system instructions at intervals. Summarize the context with integrity checks. And for anything high security, just keep the conversation length and start fresh more often. If your agent has persistent memory across sessions, that memory needs the same treatment as any other sensitive store. encrypted at rest, access control per user, and periodically review for poisoned entries. A poisoned memory doesn't just cause one bad response, it can influence the agent indefinitely. Let's talk about how we can do incident response for AI. When something goes wrong, AI incident response needs steps beyond traditional incident response. Model output forensics. What did it actually produce and why? Prompt analysis. What input triggered it? Guardrail effectiveness review. Which control actually failed? And an honest assessment of downstream impact from whatever got produced. For the worst cases, you need break glass procedure. The ability to disable a model, quarantine output, or reroute traffic to a fallback when documented approval, and immediate notifications to security leadership every time, no quiet exceptions. And for ongoing monitoring, one signal is worth watching closer than almost anything else. A sudden drop in your model's refusal rate can mean a jailbreak technique just started working against you live right now. Let's recap what we have learned in the full arc. ABAC beats RBAC for real multi-tenant LLM platforms. Zero trust means verifying every request, no exception. Second, vector databases needs the same security control as the document they represent. Embedding inversion is real. Access control for RAG has to run at a retrieval layer, not just the original document store. Context window poisoning is a multi-tenant attack. Defend with periodic reinjection and integrity checks. AI incident response adds model forensics and guardrail review, and a dropping refusal rate is your canary in a coal mine. That's the full arc. From why self-attention makes prompt injection possible in episode 1 all the way to identity, memory, and incident response today. Everything in between connects the risk, the attacks, the governance, and the defense that actually hold up. If you have made this far, you know more about AI security than most people building AI procedure right now. Thanks for watching the whole series. If there's a topic you want a deeper dive, drop it in the comment and I will see you in the next one. Thank you.